A crane pulls upward on a 250 kilogram bin with a force of 3,200 newtons. We want to calculate the force of gravity on the bin. Draw a free body diagram, that's FBD. Ignore any air resistance, determine the magnitude and direction of the net force acting on the bin, and then we'll use Newton's second law to find the acceleration of the bin. All right, so basically what's happening here is we're building up to this final question of find the acceleration on the bin. So the first thing I'm going to do is draw a picture. I know that's kind of like the second part of the question, but I like to draw a picture first. Convenient. Oh, so we have force, gravity, and then I'm going to call this the probably force crane, FC. And so this is going to be a free body diagram. So we drew all the forces involved. We have gravity pulling down and a crane pulling upwards. And so we know that force crane is 3,200 newtons. That's supposed to be an N. And then we want to find force gravity. So force gravity, that's a G, will be mass times gravity. When in this case, it's going to be 250 kilograms, which is the mass, times the gravity, which is 9.8. Pull out a calculator on clear. 250 times 9.8, see 2,400, 2,450, 2,450. Okay, and that's going to be newtons. So we drew a free body diagram, check. Calculate the force of gravity, check. Ignore any errors in terms of the magnitude and direction of the net force. Okay, so I'm going to skip to the second part, or Newton's second law. So Newton's second law is something along the lines of sum of all forces. That's a terrible summation symbol. Sum of all forces equals mass times acceleration for an object. So in this case, the sum of all forces is going to be force crane plus force gravity. So the way I'm going to write this is I'm going to say the sum of all forces is force crane minus force gravity. You might be thinking, well, this is the sum of all forces. Are they supposed to be added together? Yes. So you could view this force gravity as just a negative force because it's going downwards. The key idea here is that force crane and force gravity are going to have opposite signs because they're going opposite directions. And then I'm going to choose the force crane as being the positive direction. And that's why I have force crane as positive. And for some people, they might be like, oh yeah, it's obvious, you don't need to mention it. And it's true, but sometimes the technical details are important. Sometimes mass times acceleration. So this is the sum of all forces. And so the acceleration is going to be force crane minus force gravity all over mass, which is going to be 3,200 minus 2,450 all over 250. This is kilograms, that's newtons. And one thing to notice here is when you subtract two things, you're going to have the same units. In this case, they both have the units of newtons, which is good. So it means that we're not completely wrong. So 3,200 minus second answer, which is the 2,450. Divide that by 250. And, oh, nope, don't want that. Go back, delete. And we have 3. And acceleration is going to be measured in meters per second squared. Specifically, this is positive 3. And so this positive means it's going to be moving the same direction as the force of the crane. So it's going to be moving upward at 3 meters per second. Blah, 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 blah. Yep, looks like we answered the question. And that's how I would approach this problem. So I'm kind of breaking down Newton's second law and how to use it to find an acceleration given numerous forces that he add together. So I hope that helped. See you next time.